Hello, everyone, and welcome. This is Professor Thayer with you here today to talk to you about functions, the topic of this week. So actually, we're going to cover functions over 2 weeks because they are a kind of a big topic and something that's a little bit complicated. They may be a little different than some other kinds of programming concepts, but we're going to take it one step at a time and hopefully get you through all this. All right, so let me go ahead and share my screen. And we'll go ahead and get started. So here we are. All right, so starting with the functions, we're going to start off with the nuts and bolts of this topic, talking about the purpose of the functions and the syntax, how you're going to define them, and we're going to cover a number of topics over the next 2 weeks, like we were mentioning. So what is a function? A function is a block of organized reusable code that performs a single action. Now, when we're thinking about organizing our code, we want to take that code and we want to organize it into bite-sized pieces. We want to have one task per one piece of code. So when we're thinking about larger projects, we're going to think about taking that bigger project and breaking it down into some smaller pieces, and then having each function do one particular piece. So here's just a little preview of a function. We'll be talking about how to set this up in greater detail as we go through the material. But as you can see here, this is just a very basic function that has a greet, and it's going to print hello and the person's name, for example. So why are functions useful? In fact, it's possible to program without using functions at all. And actually, I programmed for some 20-something odd years and had never written a function in my life. And so you might think, well, you know, functions are difficult. Functions are hard to understand. They're conceptually a little bit challenging. Why do I need to even do this? Well, there are some important reasons why we want to do this. First of all, for modularization of the code, making it into those individual packages. The same task can be done at multiple points in the program without having to copy over your code. So for example, if you need to calculate the square of x, where you want to do x squared, you might type x equals x times x, and you might do that in multiple points in your code, which is fine. It will work, but what if you just had this bit of code that simply just took in the value and then just squared it? That would be so much better, especially when the task that you need to do becomes increasingly complex. So if you copy your code, the problem is that the copy of the code would require you to update each individual copy of it every time something needed to be updated or fixed. Maybe you find a bug in it, you say, oh, okay, I gotta go and fix it, and you fixed it in one copy, but you missed another copy, and you think it's working, but it's really not. It's very error prone. So we might want to take the code and just make it into one copy and update in just one place. It also allows you to organize the code. It makes it easier to get the big picture of how the program works. So as we get into more and more of the coding, we're going to talk about the organization of the code, but the basic idea here is that you will have your functions at the top, and then you'll have your function calls below. And so when you actually write your code, what that means is that then your function calls can come one after the other without the intermediate code cluttering up your view, so that you can then read the code from start to finish and get a good idea as to what's happening, whereas the actual code that the calculation is actually, where the calculation is actually happening, would be elsewhere physically on your document, and it makes seeing the big picture much easier. It also means you can share your code beyond the program in which it's written. So we can call the function from other programs and share the code with other programmers. Now you're going to encounter that when we work with some of the built-ins. And what this means is that you can load a library of somebody else's functions, and then you can use those in your code. And so suppose you wanted to share your functions with somebody else. Well, you can do that, but you need to put that code into the functions before it can be shared. There are other data structures that will allow you to do this, but generally you need to package that code up so that it can be shared across between different users. It also means that you can use your own code in your own other scripts. So generally we'll be just writing one script per project. So like one script for your lab, one script for your homework. But as you become an increasingly savvy programmer, you may want to have multiple packages. So you might have multiple bits of code, and then you want to use something, but you already wrote it in another piece of code. So if you've done it in the functions, you can do an import, and then you can just use those functions instead of having to write them again. And similar to the problem with copying the code, if you just have one place where you store all your code and you can use it multiple times, it does make it a lot less error prone. So those are some of the reasons why functions are useful. So you've actually been using functions for a long time, although you may not have really known this. So this is a snapshot of the Texas TI-30X scientific calculator that I had when I was in high school. And you probably have worked with a similar scientific calculator, or maybe you've worked with the TI-80 series for your graphing calculator, but surely you've come across this X squared button before. There are, of course, many other function buttons here, the sums. Then we have the various functions here for doing the logs, for doing the trigonometric functions. Here's the X squared, here's this, well, any number to any power. Here is the square root function. So there are a number of functions, and if you use the second function to access the blue buttons up on top, you can get even more. So consider that X squared button. How does it work? How is this like a function? Well, basically, it's going to illustrate a lot of the important things that we need to keep in mind as we're thinking about functions. It's going to take an input value of X. So you would type a number, right? You want 2 squared, right? So you input a value of X, then the calculator computes the square of the X value when you press that X squared button, and it displays the answer onto the screen. So all of these things are very familiar. Some of the things that this illustrates is a packaged way of reusing the same function. So you would want X squared to work whenever you type some number, and then you press the X squared button, it will just square it for you. So you can use that over and over again. And by pressing that button, it says, make this execute and calculate the answer. And then that answer is provided to you. Functions will work in a similar kind of a way. So we're going to come back to that example. For the moment, let us delve into how we can actually define the functions. So let's say you wanted to write a function. This is how you'll do it. It has these major parts. You'll have the definition line, and then you'll give the name to your function, and then you will have any input parameters. So this is in the header. Then the header also has this here, which is known at this green part, which is known as the doc string. That stands for documentation string. And this will include any information about the function. It will include the signature, which tells the type of the input and the type of the output. And then it also explains what the function does. This one greets the user using name. So here we're going to set a variable called message, and that's going to equal to the hello, and it's going to be concatenated with the name, which came from this right here. And then it will return the message. This down here is our function call that is calling the function, making use of the name of the function right here, and it's providing a value for the variable name. So here we have the string, and here we have name. So the function parameters are the input variables. The parameters are defined as part of the header, so that's right here. So in our recent function call, we just had hello max. Here's the name of the function matching up. And here is the string max, which matches to the name. So when we say that there's an implicit variable assignment taken from the function call argument. So here's our function call argument. This is just like when you do, you type some number and then you type the square root on your calculator. That input value that you supply is the argument of that function. And similarly, this is the argument of the hello function. So of course, arguments are not limited just to math numbers. They could be also strings, as is being shown here. So you could send up any kind. And so here we will send up the name of my dog, Max, up to name. And so there is an implicit variable assignment here. What we mean by that is there's nothing here that says, oh, this should say name, sorry. There's nothing here that says name equals Max. What this says is it says that there's an implicit variable assignment. Sorry, this is a typo. This should say name equals Max. So we don't have that explicitly in the program, but because this is the function call, what's going to happen is name will take on the value of Max when we actually call this function. The assignment of the parameter values is done implicitly. A function may have any number of parameters. There could be one, there could be no parameters at all, or there could be many parameters. In this case, we have one parameter. Notice that the parameters are found within the parentheses. That is how we identify that they are a parameter. Now, we've kind of been seeing how the functions are called already, but let's just take a moment to focus on that right now. A function will not execute unless it is called. This is a very important point. Many times beginning students will write a function and then they'll do run module, and it appears that their code didn't do anything. They say, well, why doesn't it work? Here's my function right here, Professor Thayer, it's broken. And so the reason is often because they have failed to actually call a function. So having a function just tells the program, this is what you need to do. It doesn't explain how to do it. In the sense that, I mean, it doesn't actually execute it until you actually call it. So we could call or invoke a function and use the function name followed by the needed arguments in the parentheses. So we could run the function and this would cause the function to execute. So it may cause effects. This means that something could happen, which kind of makes sense. I mean, why would we run the function if it didn't actually do anything? So when we run the function, it will do something. All functions return something, although some functions return none, and we're going to have more to say about that. So here we have our definition, and here is our doc string, which explains the types for the inputs and outputs, and it gives the basic summary of what is happening here. And then we have the message, and then it's going to return that message. So the hello function is called with the parameter name, which we get right here. And here we're going to send up the value of Max for the name. Next, we're going to talk about the variable scope. The variable scope refers to the place where the variable is able to be used. So just because you have a variable doesn't mean it's always available. And so you might wonder, well, how does that happen? Or that sounds confusing. Well, yes, it can be confusing, but that's why it's important for us to understand what the rules about the functions are. To use a variable, first of all, obviously you have to define it. If you haven't defined your variable, you're not going to be able to use it. You cannot use a variable before it is defined. You'll get an error. The value of the variable may change over the course of the execution of the program, which kind of makes sense. Because if you could never change the value of the variable, then how would you ever get anything done with your programs? You really want to have that ability to assign a value to a variable, and then you do something, and then you can update the value of that variable to reflect those changes, like keep adding as you do a running total. The value of the variable may change, and we keep track of the available variables and their values in the variable table. So let's just take a little bit of a look at some of these things in more detail. So here we've just started up our Python idle, and look at what happened here. They tried to do x plus 2, but x has never been defined, right? That's the problem here. So they got an error, and so it says x is not defined. And that's because we haven't defined x yet. We just restarted the idle. So here we're going to go back and say, all right, Python here, x equals 3. And now we try x plus 2 again. And so now x is defined because we have defined it just above. And so that is fine. This gives a sense of you need to define your variables before you try to use them. Now, we may also want to keep track of our variable values, and we can do this in the variable table. Now, the variable table does exist in Python, but it doesn't exist as such as it would be represented for humans to read. So when we make the variable table, that's for us to understand what the values of the variables are. Oftentimes, if you run your program and something doesn't work, one of the first things I'll be thinking about is what's going on in the variable table. Have you written it out? What do you think the value is? And let's compare that against what Python thinks the value is. So variable tables are very practical and quite helpful for the debugging process. So here we have x equals 3 and x plus 2, which now defines x. So we'll get a 5. So when we do a variable assignment, that's what causes the variable to appear in the variable table. So here it is x, and it has the value of 3 from this line right here. Then it reports it out, and now we say x equals 4. This means we've overwritten the value of x. So you could update your variable table. So again, the only variable we've defined is x, and instead of being 3, it's now going to be equal to 4. And so we can update that variable table, and we can then see how that evolves over time. So getting back to that variable scope idea, let's talk about those local variables. The local variables of a function are the parameters in any variables defined inside of that function. Scope, which means the region of validity of a local variable, is only in the function body. Like local variables act like scratch paper for a function. When the function call is over, they disappear. Now, this may seem a little bit disturbing to you. Why is it that we've defined some variables and it's going to be deleting? That doesn't always sit well. And so let me ask you this. What if you were using your calculator and you pressed the x squared button and it remembered that last week you did x squared for 19, and that's somehow going to affect your calculation of 2 squared today, which you're now trying to do on your calculator? Well, of course, 2 squared should just simply be equal to 2 squared. There should be no memory of using your function before. And of course, 2 squared should simply just be calculated based on the number 2 and squaring it. And so it gives this idea of erasing. After you have used your calculator, you don't want the memory of whether it calculated this number before, how it had calculated it, right? You don't want any of that information. You simply just want it to do the task that it says it's going to do. If it promises to square something, you simply want it to just square it. And so that's why we have the local variable concept. That is, when the function runs having a certain variable in it, then it should calculate it with that variable, report the answer, and then forget it, right? So it'll be ready for the next time to calculate on whatever input you decide you wish to use. So that tells us about the scope of a local variable. It's only in the function body, and then when the function terminates, then all of those local variables also are going to terminate. We identify them because they are located inside of the function. So local variables thus act like scratch paper for a function. When the function call is over, they will disappear. All right, so we could take a look at this function here called double, and it takes the input of number, result equals number plus number, and this is going to return the result. So we see that number is a local variable because it is a parameter of the function. So that's automatically going to be a local variable. We also have another variable here. It's called result. Result is equal to number plus number, and result is also a local variable because it is inside the function. So result and number are both of our local variables. That makes two local variables, and these variables are going to be affected when we do that function call. In contrast, there's also such thing as global variables. They're variables defined outside of any function, and they're the kind of variables we've been working with so far. They're basically just the variables that are in main. They're just in the program. They may be looked up but not assigned from within the function. And I'll tell you that that is a mostly true statement. In fact, there is a way to change that, but we are not going to tell you that right now because we want you to keep these ideas separate, and we'll tell you in a few weeks as we get closer to working with your project. So it's just really when you're going to need to know this information. When you're trying to assign a global variable from within a function, instead creates a local variable with the same name. So local variables do what we call shadowing global variables with the same name. So this can be a very dangerous situation because if you're not paying attention, it can be very confusing. So we have x equals 3 inside, and we have x equals outside, and x equals 4 inside the function. And then we're going to print something about this x. Which value is it going to have? Is it going to be 3 or is it going to be 4? And so we see that actually it's going to print the x equals 4 because that's the local variable. So it will take a precedence that will pull the value from within its own scope. And so it will choose 4. But we also have a global variable called x, which is still in existence simultaneously. And this is why we have shadowing. The idea of shadowing means we have multiple copies of a variable that looks to be the same, but actually it's not because they differ by their scope. Global variables should be used sparingly. When a function depends on the value, it should generally be passed in as an argument. Global variables are for program-wide parameters, and that would be tedious to pass to all functions. So I would also just point out that a global variable does not need to have the same name as the local variable. These things really don't matter. So here we're going to just take another look at the greet function. So here we're going to have greet of name, and we'll print hello and the person's name, and then we'll just return. So let's set the name to me, Professor Thayer, and we'll have greet of name. So this sends Professor Thayer up, implicit variable assignment to name. Then we're going to actually print this. Hello, comma, space, and then the person's name, Professor Thayer, and then we will return. Notice that we have a name out in main, and we also have a name as a parameter here. So there are two copies of name, one local, which is this copy up here, and one global. Now let's contrast this with doing this a different way. Notice that instead of using name, we've used x. So here we're going to do name equals Professor Thayer, and we're going to do a function call to this function with greet name, which is really the same, doing the same task. It's just that now we have name here. So because it sends up the value of the variable and not the variable itself, the name will be sent as Professor Thayer. There'll be an implicit variable assignment to x, and then it will again print hello, Professor Thayer. So the signature can be used to specify the input and the output types. This is for humans, and it is not for use by computers. So for a function to work properly, its arguments to the input and what's returned, just the output, must have the correct types. Python is a dynamically typed language, so this means Python is not going to check the types for you. But when the wrong type occurs, the errors may show up or unexpected results could occur. So as a programmer, you have to keep track of your expected types. The function signature states the types of the input and the output. And this is done using the doc string. So here's our doc string. Right here in the triple quotes, the doc string is the comment at the top of a function. It contains up to 3 parts. The signature, which tells the type of the inputs. It also tells the types of the outputs. Any restrictions not evident by the types should be mentioned. So avoid division by 0 if there's restriction on signs, or if you need to omit something. You can also just do that. So oftentimes this restriction is not really required. You can just skip it if there's nothing here. And finally, there should be a brief note about what the function does. You can use help with the doc string. So this is a Python built-in. So if you do Python help, if you use the Python help function with the name of the function, it will report the contents of the doc string. And this is why it's important to follow the structure that we have mentioned. This works for Python built-in functions, and this works for your own functions if you follow the format. Use the triple quotes for the comment and place it after the def line. It should also, of course, be indented. So here we could do help of print. Here we're doing help of hello. So we see that I am having some questions here, and this is going to work to, in fact, just make that for you. All right, well then, we're at 25 minutes, so I'm going to go ahead and put this on pause, and we will pick up next time with writing our own square function. Thanks so much for joining us, and we'll talk to you next time.